Now we will discuss about cell. What is happening in cell? In cell, there are chemical reactions, and due to these chemical reactions, we are getting electrical energy. It means cell is converting chemical energy into electrical energy. Suppose this is external resistance. And what internal resistance material of cell will offer, that is here, and it is known as internal resistance. Suppose EMF of cell is E. Now what is EMF? EMF means maximum voltage, maximum potential difference across the plates of the cell is known as EMF. Means when cell is in open circuit, at that time potential difference between the plates of the cell is EMF. Or you know that work is equals to charge into potential difference. So you can define this maximum potential difference with the help of work. Work means energy. What energy? How can we explain V in terms of W? V is equals to W upon Q. Means energy per unit charge. So we can say कि what energy a unit charge is getting from cell to complete one cycle in the circuit, means outer circuit and inner part of circuit, is known as EMF of the cell. Suppose I current is flowing through this circuit. So potential difference across R, V is equals to by Ohm's law I into R, and inside this potential difference is I into R. It means total potential difference between plates. Now it is divided into two parts. One part this R got, it was I into R. Remaining inside the cell I into R. Or we can say E is equals to V plus I, means V by R into R. Take V common. In so many years you are getting this type of numerical E upon V. Take V common and send on that side. It will become 1. Take this one on that side. It is R by R. So we are getting direct numerical on this formula. Okay, calculate the internal resistance of the cell. So what is the formula now? R into E upon V minus 1. If you know the potential difference across the external resistance, if you know the EMF of the cell, you can calculate internal resistance with the help of this result. A very useful result. Many times we are getting numerical directly on this formula. But if we have more than one cell, how to connect cells to get maximum currents? Now we will discuss that point. It means we have so many cells with us. We can connect the cells in two ways. If we are connecting like this, end to end, means series combination of cells. Suppose I have n cells. I have n cells. This. It is my external resistance. I want current in this, and it is key for switch on off. Internal resistance of each cell is small r, and EMF, suppose it is E. EMF is E. What current I will get in external circuit? See, if I am saying the potential difference is E, It means potential difference between these 2 points is E. If I am moving from left to right, again there is a drop of potential by E. Again one drop of potential E. So from this end to that end, total drop in potential is N times E. So now this combination of cell will behave like a single cell whose EMF is NE. What is the current? We know that current in circuit means total EMF divided by total external resistance plus total internal resistance. External resistance is capital R. Since all internal resistances are connected in series, so we know the formula for combination of series. So total internal resistance will become N into R. Now two cases arises. If external resistance is very greater than internal resistance, so we can ignore internal resistance. So current by one cell, it should be E upon. If we can ignore small r, it will be this. What is this? Current from one cell. It is current from one cell. And from N cell, what I am getting? I is equals to NE upon R, means N into current from one cell, means my purpose is solved. From N cell, I am getting N times current, which I got from one cell. But reverse the condition. If internal resistance is very big than external resistance, what will happen then? Current from one cell, in this case, current from one cell is equals to, now you can ignore capital R, so you will get I is equals to E by small r, and current from N cells, what we are getting, ignore capital R, so you will get an E upon an R, means again we are getting same current, means after using N cell, if I am getting current from what I was getting from one cell, so no use for this type of combination. It means series combination of cells is useless if internal resistance is very greater than external resistance. It is useful only if external resistance is very greater than internal resistance. So if internal resistance is very greater than external resistance, don't use this combination. Then we will go for parallel combination. So remember, they can ask in conceptual problems, if you can avoid internal resistance of a cell in comparison to external resistance, which type of combination we should prefer? If we can avoid internal resistance, then we have to use series combination. If internal resistance is very bigger than external resistance, then we will go for parallel combination. If both are of same order, we will use mixed combination. Then we will go for mixed combination. What do you mean by mixed combination? Suppose I have M into N cells. I have M into N cells, each cell with EMF E. each cell with internal resistance R. I am connecting these with external resistance R. What current I will get, we will see. I am making m rows of n cells. These are n cells. Each of EMF E, each of internal resistance R. I am making m rows, this type m rows. And it is by external resistance. Key for switch on off. From figure, it is clear that in one row, total potential drop is NE. We know that in parallel, what potential difference is total? It will be individual for each branch. It means if each branch has potential difference of NE, total potential difference, it should be NE. Parallel potential difference is same, series current is same. Now, internal resistance for each branch, since in each branch our resistances are in series, so internal resistance of one branch is NR. For MR, it should be 1 by NR, 1 by NR, M times. So what I am getting? M by NR. So R dash is equals to NR divided by M. So what current I will get? E upon external resistance plus internal resistance. So what I am getting? It is MNE divided by MR plus NR. How to get maximum current? Tough to tell. So I am changing the expression like this. I am writing denominator root MR minus root NR whole square I will get these two terms. Extra term I am removing by adding that root MN RR. Now we know that only with the help of this term we can maximize the I. M into N, total number of cell, is constant. EMF of each cell we cannot change. External resistance given to us constant, internal resistance constant. Only what you can change, the number of cell in one row. Means if you have 6 cells, M into N is 6 constant, but you can change M and N. Take M 1 row, N 6, 1 row of 6 cell, or make M 2, N 3, 2 rows of 3 cells or 3 rows of 2 cells. You can change only m and n. So by changing m and n, we can adjust this term, but it is perfect square, cannot be negative. Its minimum value is 0. When denominator is minimum, I should be maximum. So for maximum value of I, this term should be 0. If it will become 0, you will get current root m and e. It is the maximum value of current root RR. And when it will happen? When you keep MR and NR equal. It is the condition for maximum current. The number of rows into external resistance, it should be equal to number of cells in one row into internal resistance. Getting my point? So it will be maximum then. Next term is Wheatstone bridge. You know that what is Wheatstone bridge? In 12th class you have derivation, and we have also derivation in our theoretical slides. It is Wheatstone bridge. A, B, C, D. It is a galvanometer. What is the principle of Wheatstone bridge? We proved in our theoretical derivations that if P upon Q is equals to R upon S, you will not get any current in this branch. Means deflection in galvanometer will become 0. It means if P upon Q is equals to R upon S, at this time B and D, they will be at same potential, so current will not flow in this branch. So if there is resistance, we can ignore that resistance. It is the principle of Wheatstone bridge. By using this principle, we are calculating a known resistance in labs by meter bridge. You know that in meter bridge, you are calculating the unknown resistance. In place of R, you are putting some known resistance, and P and Q are the two parts of the wire. So what we are getting there? We are getting, if null point you are getting at length L, so you can calculate a known resistance by this formula. If null point is getting at a length L, so by putting the values in this, we can calculate a known resistance. So in meter bridge, we are calculating one unknown resistance. And last, two important points are related to, one is Kirchhoff's law and one is potentiometer. First we will discuss about potentiometer. What we are doing in potentiometer? In potentiometer, we are comparing the resistance, the EMF of two cells, and we are calculating the internal resistance of a cell. See, this is known as primary circuit of potentiometer. In this you have one battery, one rehosted varying resistance, and one 10-meter long wire. What we are doing here, we are developing a potential difference across the wire AB. It is of uniform length. If we are developing a potential difference V and total length of wire is L, it means potential gradient should be V upon L. Means if you move a unit distance from A to B, there will be a potential drop of V upon L. What we are doing, it is secondary circuit. If you want to compare the EMF of two cells, put that cell in this circuit. It is a two-way key. It is a two-way key. A galvanometer, it is jockey. It is cell E1, it is cell E2. First we are putting key here, means E1 cell is in circuit. E1 cell try to send current in this direction, DA, DA, JB, DA, JB. But this potential difference between A and J, due to battery, it will try to sell current in this direction and your cell will try to send current in this direction. But if potential difference between A and J is equal to potential difference between the two plates of cell, it will balance it and you will get no current, means in galvanometer no deflection will be there. So remove the jockey on the move the jockey on the wire AB. You will get one point at which you are not getting any deflection in galvanometer, means at this length potential difference between A and J is equal to the EMF of cell. Suppose you are getting this at length L1. So potential difference between A and J should be rho L1. Now it is equal to E1. Now close this key and open this key. Now E2 is in circuit. Again find null point. Suppose now you are getting at length L2. So now rho L2 is equals to E2. It means E1 upon E2 is equals to L1 upon L2. In this way, you can compare the EMF of two cells. One more experiment is there. In this place, we are putting one cell connected with a resistance box RB. Again we are getting a null point on potentiometer wire and we are putting an infinite resistance plug from this resistance box. It means in this part now resistance is infinite, so cell cannot send current in this own circuit, and if null point is there, it means cell is not selling current in that part also. So it means your cell is in open circuit and find that balancing length. Suppose it is L1. Now put some resistance R in circuit with the help of resistance box. Get null point. Cell is not sending any current in upward direction. But since cell is sending current in this resistance box, means its own circuit it is sending current. So at this time its potential difference will balance on potentiometer wire. So you will get E upon V, L1 by L2, and we proved one formula, R is equals to capital R into E by V minus 1. With the help of this formula, you can calculate internal resistance. Next, Kirchhoff's law, very important. Kirchhoff gave two laws. First, it is law of conservation of charge. What is first law? At any junction, summation of current should be 0. What it is saying? At any junction, summation of current should be 0. Suppose in circuit it is a junction. I1 current is going towards the junction. I2 current is going towards the junction, I3 is moving away from the junction, I4 is moving away from the junction. So what Kirchhoff's first law states? Algebraic sum of all current should be 0. What is sign convention for algebraic sum? Current which are moving towards the junction should be taken as positive, and which are moving away from the junction should be taken negative. It means I1 plus I2 minus I3 minus I4 is equals to 0. Or you can say for each junction, current entering into the junction and current leaving the junction should be equal. It is actually law of conservation of charge. What second law states? In every closed mesh, the summation of EMF of cells should be equal to summation of product of current and resistance. What is the sign convention for this? If you are moving in the closed mesh and negative plate of cell, you encountered first with the negative plate of cell, take its EMF positive. If first you encountered with positive plate, take its EMF negative. And for this, if you are crossing a resistance and direction of your motion and direction of current is same, take this product positive. If direction of your motion and direction of current is same, take it positive. Otherwise, if they are opposing each other, take it negative. So these were Kirchhoff's law, and Kirchhoff's second law is in actual law of conservation of energy. So remember, for conceptual problem, first law of Kirchhoff is law of conservation of charge, and second law is law of conservation of energy. So it was the complete theory of your 10th unit current electricity. Now we will go for our assignment of 45 questions. Thank you.